Hi, Mental Lovers. I'm Mira.
And I'm Zahra. You are watching a video about Maxima and Minima. Follow on close with the file.
Okay, let's begin. Okay, now we learn about maximum and minimum value on the closed interval.
If I have a graph like this, yes, and I have a closed interval, this is a point A and this is point B. So this graphs will be in a closed interval between A and B like this. I have three critical points, A, B, and C. Then I can say that point A and C is relative maximum points. Because of what? Because when there is, I can see this point P and Q, FP and FQ is always greater than Fx, and Fx is the nearby this interval. Now, what about this point B? Point B is also relative minimum interval. Because of what? Now, let's see this point R. This is when Fr is always less than or equal to Fx during this interval A and B. C is absolute maximum points. Fq is the highest value of function Fx. Fq is the highest value of Fx during this interval A and B. Now, point B is also the absolute minimum points. Okay, why don't I choose this point D? Because this point D is not a critical point. Fr is the lowest value of Fx between this interval, and Fr is a critical point. That's why I don't choose D, because D is not a critical point. That's the problem. Okay.
And this is an example. We need to find the maxima and minimum value on closed interval, and we have closed interval on 0.3. So first we have to differentiate of x, and we get a function x, and then we have to factorize it. So we get the value of x equal to and x equal minus 1, and this value is critical point, that is minus 1 and 2. But we talk about closed interval. We have closed interval on 0.3, and the critical point is only 0, 2, and 3. To get maxima and minimum value, we have to substitute the critical point into the first function, and the first function it is the x, and we just make a table and write the x in Fx. And it is on 2.3, and first we write 0, 2, and 3 to substitute in function, first function, and we get 15, and the second also, and the third also we substitute into the first function, 6 on 0.3, and 15 is maximum absolute, and minus 5 is minimum absolute. It is maximum because 15 on 0 is 15 is highest, and minimum minus 5.
I have a function fx and x minus cos x during this interval. If you want to find the absolute maximum and minimum value of this function during this interval, just find the first derivative of it. Sin x is cos x, minus cos x is minus sin x, means this will equal to cos x plus sin x. We need to make it 0, so we just minus cos x equal to sin x, like this. Sin x is plus, sin x is plus during first and second quadrant, and cos is minus during the second and third quadrant, so it will be in the second quadrant. During this interval, it means that phi over 2 and y. Okay, to find value of x, we need to find the value that cos and sin is same but different sign. So it will be 45 degree, right? Because this interval, so it will be 90 degree plus 45 degree, it will be 135 degree. Just check to plug in this. Minus cos, it will be half of root 2. That's same, correct, cool. Okay, now just make a table like this. The first column is x, second column is x. We need to find out this value: 135, 0, and 5. 5 means 180 degree. 0, 135, and 5. Fx is, as you saw, sin x minus cos x. We plug in the 0, 0 minus 1 will be minus 1. It will be like that. Half of root of 2, it will be root of 2. And it will be 180 degrees. 0 minus 1 will be 1. Okay, we can find that this is the lowest, it is minimum absolute, and is the highest, it is maximum absolute.
Okay, that's all about maximum and minimum value on closed interval. We hope you understand. Bye-bye.